Okay. Hey, folks. Yeah. Welcome. I'm excited to be joining in DevCommunity Summit this year. I've been a big fan of Android Summit in the past, and I'm excited for the new format here, and excited to see some familiar faces in the Zoom chat and stuff here. So hopefully you're in the right spot. We're going to be talking about how to demystify and optimize your Android Gradle builds. For those that don't know me, my name is Nate Ebel. I'm an Android developer, Android instructor, Kotlin GDE. I spend most of my time these days working at a company called Premise, and then also do some developer training and instruction, podcast, YouTube, all that kind of fun stuff. Basically, I just really enjoy helping people learn about Android development, about mobile development in general. And that's why I'm here with you all today. So like we said, we're going to be talking about Gradle today. And I think just to warm us up a little bit here, we're going to start by just asking this question. What is Gradle? And I imagine we might have some different possible answers to this. So we're going to have a multiple choice question here. Feel free to shout out at your computer what you think the answer is. I won't hear it, but it might be fun for you. Feel free to throw an answer in the Slack channel if you feel strongly about one of these. But yeah, what is Gradle? Is it A, the source of approximately 94.3% of Android dev Twitter traffic? Maybe. We'll have to check the math on that, but that definitely passes the smell test based on folks I've worked with. Is Gradle a viable means of heating a small room? Based on my experiences working from home in my tiny little closet office, I think this one has a strong possibility as well. Is Gradle a general purpose build tool used for Android and for other projects? Maybe. It's not as exciting as some of these other options, I think, but it could be. Or is it D, all of the above? Well, it is in fact D, all of the above. As much as I wish this whole talk was about Android Twitter traffic or heating a small room via your laptop fan, it is in fact all of the above. And probably most relevantly, it is a general purpose build tool for Android and other projects. And so that's really where we're going to start today. Gradle and the Android Gradle plugin are really kind of the backbone of modern Android development today. We don't think about it all the time, but when we create a new Android project, we click the little green run button. It's really Android Gradle plugin and Gradle working together to build our project, to deploy it, to build our libraries. And thankfully, we don't have to think about it all that often. However, that does start to break down. So while it might be the backbone of our project here, and we don't think about it that often, it also can really be a source of a lot of frustration and loss of productivity for developers. And this is a big problem for a few reasons, but one main reason, which is that builders want to build. As developers, we like to build things. We don't want to be waiting for things to build. We don't like waiting for CI builds. We don't like waiting for our local builds. We want to make a change, build it, deploy it, validate that change, and then do it all over again. So we can rapidly build whatever it is that we need to build and just keep moving forward. So with that in mind, that brings us to this concept of developer productivity engineering. And if you're not familiar with developer productivity engineering, that's okay. But basically, developer productivity engineering, or DPE for short, is something that our team has bought into and invested a lot of time and effort in. Basically, at kind of a high level, DPE is the use of sort of data analytics and different build optimizations to ensure that devs spend more time building and less time waiting around for builds. And just sort of anecdotally here, our team, since starting down this path, has been able to sort of leverage these practices, these tools to optimize our build times by as much as 80%. So just like for one small example here, when I started on my current team at Premise Data, 18 months ago or something, our PR builds took something along the lines of 45 minutes to build a PR. Today, they take around 6 or 7 minutes. Now, a huge part of that was the optimizations around our Gradle builds, and really, it's a big inspiration for everything we're going to talk about today. So these patterns, these strategies that we're going to be learning about, they can have a massive impact on your project. So to highlight where we're going to go in this talk, we're going to start with just some basic understanding of our build. Then we're going to look at ways to profile our builds, to understanding what's going on under the hood, where things are slow. We're going to look at how to optimize our builds to then make them faster. And finally, we'll close it out with how do we maintain our builds. Once we've invested in them to make them faster, we want to make sure that they stay that way. So we're going to kind of peel back the veil on our Android builds and hopefully get to a point where we can have faster builds and just be more productive, just keep building things. So my hope for you then is really two things. So from this talk, I hope that you will have a better understanding of what's going on kind of behind the scenes when you build your Android project. And then two, I hope that you might be able to identify at least one sort of tool or optimization that you could try out literally today. My hope is that everyone would find something, go back to their project, go back to their team, create a PR, and immediately start seeing faster builds. So I'm going to cross my fingers for that. And with that, we'll just go ahead and jump in. So let's think about how we understand our builds. And I think a good place to start for this then is the big green button in Android Studio. So we create a new project and we click Run App. What happens behind the scenes? How do we go from clicking that button to seeing our APK built, to seeing our app deployed onto our emulator? What's going on? So if we click that button, we can pull up some build output and we'll see something that looks a lot like this. We see executing tasks and then probably a single task that looks something along the lines of assemble debug. And if you're not familiar with looking into the build output, if you haven't spent a lot of time playing with your builds, you might have some questions from this that I think would be perfectly reasonable. You might say, what is a task? You might think like, what is this assemble debug thing going on? So this is where we're going to start. What is a Gradle task then? Well, Gradle task is basically a single piece of work for a build. It could be something like compiling a single file. It could be zipping up a bunch of files into some archive. It could be generating your outputting Java doc. It could be compiling together and packaging all of your test results. It's basically just a piece of work that you want to be able to do repeatedly as part of a larger build. Now, where do tasks come from? Well, tasks can come from a variety of places. And again, we kind of take this for granted a lot of times. We tend to maybe just click the button and it runs and we don't think about where any of these things are coming from. But at a lower level, tasks come from Gradle itself, just as kind of the infrastructure available to any Gradle project. Tasks can come from our own custom built tasks that we could add to our build scripts, or they come from plugins. And each of these has kind of their place potentially in your project and in the story of keeping your builds fast. So in terms of tasks that come from Gradle, there's kind of a small subset of tasks that are available on pretty much any Gradle project. And these are things like the help task, dependencies, which will list out all the dependencies for sort of your root level project. There's the tasks task, which is kind of one of my favorite ones just because it's a bit of a tongue twister, but this will basically just tell you what tasks are available for a project. There's the projects task, which will show you sort of what sub-projects are connected with your project. And then you can look at any Gradle properties that are associated with it. So this is not all of the tasks that come, but I like this set because if you're wanting to just get more familiar with Gradle, these are a set of tasks that you can use when you sit down to any Gradle project and you can run these tasks and start querying information about the project. You can use it to see what dependencies are there, what tasks are available for you to run. You can see like what sub-projects are available. So it's a good place to start to just be able to feel a little bit more confident in working with Gradle. Now, like I said, you could also write custom Gradle tasks. And in fact, if you create a new Android Studio project today, there's typically an example of a custom Gradle task. It's usually this clean task. And so this is two examples here of just how simple it can be to define a custom Gradle task. We could do so in our build scripts. So whether that's build.gradle or build.gradle.kts, and we could define tasks that look something like this. So the clean task will sort of delete the build directory for the project. This hello world task here will just print hello world whenever it's executed. So this is kind of like the basic DSL example. This is very simple task just to illustrate how simple it actually can be. You could also define tasks as basically just classes defined in Groovy or defined in Kotlin. And the point here that I'm trying to make is that there's no real magic here. Tasks are basically just classes or functions like anything else that we're comfortable working with. And they tend to operate in very specific ways that we'll look at later. And once we start to understand that, it's easier to think about working with them and trying to understand why they might be breaking down. So finally here, then, we have tasks that come from plugins. And these might be things like assemble debug that we already looked at. So this is an example of a task that might be coming from the android-gradle plugin. We might have an Artifactory publish task coming from the Artifactory plugin that might help us, publish our library jars to some internal Maven repository. App distribution upload debug. This is an example of a task coming from the Firebase app distribution plugin. So these are oftentimes kind of the level of tasks that we're working with. These things that do very specific things like, push a build to Firebase app distribution or build our APK. And these are examples of things that really come specifically from plugins. Now, plugins, we've mentioned it, we haven't defined it yet. A plugin basically is a collection of new Gradle tasks, domain objects, conventions, and kind of core extensions that all basically serve together to build some project type. So like the android-gradle plugin, for example, is all about building our Android applications and libraries. And so it provides all of the tasks needed to do so. So we consume third-party tasks very regularly. We can also create our own plugins. And again, there's no real magic here. So here's an example of a very basic plugin where we define our own plugin by creating a class, and we extend the plugin class and we override the apply method on it. So in this case, we're simply calculating what version our project should have. And then we set that on the project configuration object. And then we can apply that plugin the same way we would apply other plugins. So again, this is just to highlight that there's no real magic here. These are classes and methods that we're used to working with. And writing custom plugins can actually be a good way to sort of consolidate common build logic and make your builds easier to work with, which we'll talk about towards the end. So we've talked then about like kind of Gradle, we've talked about plugins, but maybe the line is still a little bit blurry here. So what does sort of a very basic Gradle project look like then? Well, to do that, we're going to jump over to our command line here. So I'm just in a new working directory here. And if I just sort of list out, we see that there's nothing there. And I have Gradle installed sort of to my path here. So if I type a Gradle - version, we'll see that I have the Gradle tooling installed here and available to me. And so with that, we can do this Gradle init command. And what this is going to do is basically open up a Gradle command line interface to help me set up a project. So now I ran that and it did a little bit of initialization. So I'm going to cancel this real quick just to help make a point later. If I now list out what's in this directory, we now see that basically it installed the Gradle wrapper into this directory. And I just want to call that out. They're like, we haven't really set up a project yet. This is just sort of table stakes for making any Gradle project sort of easier to package and consume. It installs the Gradle wrapper, same as we have in our Android Studio projects, for example. So now I'm going to go ahead and go back to our init. And it's going to ask me what type of project to generate. And we want to just see what a basic project looks like. So I'm going to go ahead and select basic project. I'm going to just go ahead and leave it with Groovy build scripts, although you could use Kotlin build scripts if you wanted. And then I'll hit enter to just leave the default project name. So now if I list out what we have here, we'll see that it's added two things. It added a settings.gradle file and a build.gradle file. So what this is highlighting here is that in the most basic sense, and basically the most simple Gradle project we can have, we really just need these two things. Settings.gradle, which basically says this is a top level sort of Gradle component. This is an entry point to be able to build something. We don't know what yet, but it lets you build something. And then build.gradle provides more configuration for what you're actually going to be building. Now, if we just quickly look at what's in each of these files, it's not a lot. This is the entire settings.gradle file. And all it's doing here is setting the root name of the project. So again, very basic project, very basic configuration, nothing particularly interesting here. And similarly, if we look at our build.gradle file, this one's even less interesting. This actually does literally nothing. It just has a comment. So in our Android projects, this is where we would think about configuring the Android Gradle plugin and applying plugins and all that. But in the basic case, we don't have to. We can just have this basically empty file here. So now, if we just look at what is available to us for this project, we can run the tasks task again. And as we kind of scroll through this, we see that there's a handful of tasks, but it's in the realm of like 10 available tasks, as opposed to possibly hundreds like we might be used to in our Android projects. So we can see here, like I said, there's this dependencies task, there's the help task, there's projects, properties, tasks. So these are sort of the tasks available to any project based on this very, very simple configuration. And so hopefully the point here is to illustrate that when we think of working with our Android build, we often complain about Gradle, but actually Gradle is very basic. Gradle doesn't provide a whole lot to us. So really, the interesting functionality from any Gradle build is actually coming from the Gradle plugins and not Gradle. So this is one thing where I like to stick up for Gradle, because when we complain about our Gradle builds, a lot of times it's actually the Android Gradle plugin that we're actually mad about, or maybe we're frustrated with Groovy or something. So I think it's important to sort of recognize this distinction between sort of Gradle and the plugins. So that then begs the question of, well, what tasks are available in a brand new Android project? And that's a good question. So if we jump over to an Android project here, this is basically just a hello world project that I generated. If we look into like our main activity, it's a basic sort of compose project. The interesting thing here is this Gradle tool window. So this I open by selecting the tool window over here on the right-hand side of my screen. And when we open this up, this is showing us a list of Gradle tasks available to this project. And if I start poking around to this, we see that there's sort of a group of Android-related tasks here. There's a group of build-related tasks here. And then eventually we come down to this other directory, and there's just this massive, massive list of tasks. These tasks are really sort of intermediate tasks. These are all the things that go from clicking the green run button to spitting out a library artifact or an APK or an app bundle. And these are all coming from the plugins applied to this project, which really, because it's such a simple project, is really just the Android application plugin and the Kotlin Android plugin. So this highlights sort of the difference of Gradle versus all the tasks coming from the plugin. So really, when we're running most of our tasks as part of our Android development workflows, we're usually running tasks from plugins as opposed to Gradle itself. So the Android Gradle plugin, then, the relationship between these two is that Gradle provides the infrastructure, Android provides the functionality, and the two work in tandem to build what we need. So where then does this start to break down? We kind of have an idea of like what's happening behind the scenes, but then why does it become slow? Like, why do we as developers sort of universally start complaining about our builds inevitably as our projects grow? Well, slow builds can come from kind of three sort of main high-level sources. We might be running our builds on underpowered hardware. We might be running really computationally intensive tasks. Maybe for some reason, part of your build is calculating Fibonacci to a huge degree. Computationally intensive things are just going to be slower. And also, and this last one is a big one, if we're building more than we really need to build, we're going to have slower builds. And thankfully, there's things we can do for all of these to help improve them. And that's where the talk is going to go. So first off, just faster machines equal faster builds. We're going to come back to this later, but really, like, you can just kind of throw money at this problem, throw a faster machine at it, and you should see faster builds. They would still be inefficient, but they would still be faster. Similarly, if you're writing custom tasks, you want to make sure that they are not overly expensive. So you still want to write good, efficient code. Nothing too exciting here, especially because most of the tasks we're working with, we don't control. So this one, there's not as much to worry about. But the big one here is we want to avoid doing more work than is necessary. So we want to avoid doing repeated work. This is really going to be a big focus of the rest of this talk. It's a big focus of the Gradle tool itself. So if it's so important, how do we know if we're doing more work than is necessary? And so to understand that, we now need to go sort of one level deeper in our understanding of our build. And we need to kind of understand the phases of a Gradle build. And the phases are initialization, configuration, and execution. So in the initialization phase, basically Gradle is going to determine which sort of projects are going to take part in your build. So if you have multiple Gradle projects in a build, it's going to figure out which ones are kind of included in the build that's being run right now. And it's going to create sort of a project instance sort of in memory for each of those. And the configuration phase, then, it's going to basically populate those project instances, and it's going to generate any tasks that are needed. It's going to calculate task dependencies and task graphs. And it's basically going to do all the legwork so that when you're ready to execute the task, it knows what it needs to run. Now, these two phases together, initialization and configuration, they really kind of happen like together. So they're often in some of the profiling tools sort of considered as like one and the same. They're separate, but they often kind of get considered together. And in a well-configured project, these two things together should take a few seconds, like in the realm of 3 seconds, 5 seconds, maybe 10 seconds or something. But if you were to test this and test the initialization configuration phase, and you find that it's taking a minute, something's wrong with your build. So to test this, a good basic test that you could go back and do in your projects today is to run the help task. So again, if we pop over to an emulator here, excuse me, not an emulator, to a terminal here, if we invoke the help task here, this is going to run the help task. The help task doesn't really do anything intense or time consuming. So basically the only time that contributes to the execution time of this build is really coming from initialization and configuration. So if you run the help task in your project and it takes 30 seconds, it might be a signal that you're doing more work than you would want to be in that initialization or configuration phase of your project. This is also not a bad way to just validate if your build scripts are sort of compiling or not. So if you're migrating from like Groovy over to Kotlin, or you're just adding new configuration logic, you might be tempted to kick off your common task like assemble to validate the script. But if that works, then you have to like cancel the build unless you really want to rebuild the whole thing. So sometimes if you just want to validate your build scripts, help is actually a useful way to do that without having to kick off a whole build. Save yourself a little bit of time that way. And now finally, the last phase is execution. This is what executes the task. At this point, the dependencies should already be known. So sort of the requested task will be run. So if we request the help task, then it's going to figure out what the task graph is for that and run all those tasks. If we run assemble, it already knows what that task graph looks like. So it'll kind of go to the root task and kick off that build. As the tasks are running, they might generate outputs. They might grab inputs that come from some other task and then generate a new output. It kind of builds up this tree and ultimately trickles up to spit out whatever output we want. So maybe it's an APK, maybe it's a bundle, test reports, etc. So if we zoom in then on just like a specific task, they all sort of follow the same rough pattern. They can take in an input, they can calculate something, and then they can optionally spit out an output. The output could be a compiled file, it could be a bundle, etc. But this sort of input-output functionality is really at the core of how some of the build acceleration tools work. So it's good to just sort of call this out and be able to zoom in and keep this sort of mental model in your mind. Now, when we execute that task and we get whatever the output is, the task is going to have basically an output status. And the status has become really helpful in understanding if we're doing too much work or not. So for any given task we run, or that is run in response to us requesting that another task run, that task could be executed, which basically means like it successfully ran. It could be up to date, which means it didn't need to run because its input hasn't changed, which means its output's not going to change. It could be from the cache, which means it needed to run, but its output was already available in the cache. So rather than rebuild that, it just grabs it from the cache and uses that instead. Or you can sort of be skipped if you're not needed, or no source, meaning just like you weren't really touched, you weren't part of the task graph in any way. And so you're basically just kind of ignored. So it's really these first three that are really crucial in sort of being able to conceptualize common build scenarios and understand if your build is working correctly or not in those scenarios. Just kind of as a jumping ahead, like a spoiler, like ideally we want as many things to be either up to date or from cache as possible, because if everything is executed, it means everything is rerunning. And like we saw before, running things is expensive. We want to avoid actually running things. So common build scenarios then. These are nice sort of high level ways to think about certain types of builds and to be able to sort of test and optimize these builds independently. So we have first time builds, we have up-to-date builds, clean builds, and incremental builds. And you've likely heard of some of these before, but if you're like me circa a year ago, you maybe weren't super clear on what all of these necessarily meant. So a first time build is sort of the idea like we check out a fresh clone of a repo for the first time on our new laptop when we're setting it up. Or maybe we're checking out a fresh clone on a CI machine. So we don't have any sort of build artifacts from previous runs. We maybe don't have a cache or anything. So we would expect this to really be like the slowest version of our build. Even if we do pull from a remote cache, this is still likely going to be a very slow version of our build, just because we don't have any previously available information to help speed up the build. So we would expect our tasks to have a lot of sort of that executed status, because it is going to have to rerun most, if not everything in this scenario. Now, up-to-date builds is sort of the opposite. So imagine we run our assemble task, it runs, does its thing, finishes. If we then run that same assemble task again with no changes to our project, ideally nothing should run. That's because everything should be up to date. If we haven't changed anything, then all of the outputs should still be there, which means all of the inputs based on those outputs should still be valid, which basically means nothing should have to rerun, and our build should finish almost immediately, like within a second or 2 seconds or something like that. So if you run the same task 2 times in a row on your current main project, and the second build actually re-executes most of the project, that's a good signal that your build is not optimized as well as it could be. And we'll look at some ways to fix that down the line. Now, let's imagine that we have done a few builds, something's not quite right. So we clean our project and then we want to rebuild. So like we saw with the clean task earlier on, the clean task often sort of delete sort of local build directories. Those build directories are often filled with sort of outputs of tasks. So if we remove those, it means that a lot of our tasks are going to need to be rerun. Now, if we don't have any type of caching or anything, then it's just going to have to rerun that build and recalculate everything. And this will be largely similar to, let's say, the first time build. However, if we enable some different sort of caches that Gradle supports, and we'll talk about in the optimization section, we can actually have clean builds that, while yes, they might have to rerun some things, they can actually pull a lot of the artifacts from the cache. So they won't be as fast as an up-to-date build, but they won't be as slow as a first-time build. And this is something that we can do a lot of testing with and try to make sure that as many things are cacheable as possible. And that can have really big performance wins for us. And then finally, incremental builds. Kind of similar to the clean build, where this is the scenario where we're building something, we change maybe one file in our project, and we want to redeploy and see the result of that change. Ideally, we'd love to only have to like recompile that one file, because that would be like the minimum amount of work. Now, because of the way dependencies and everything work, we often have to rebuild more of our project. So in the incremental build, we want to try and optimize our build in such a way that like making a small change to, let's say, a Kotlin file somewhere doesn't require us to rebuild our whole project. And so this is where things like modularization can come into play. So the key from all of this, and again, if you have like one takeaway from this to take back to your team, this wouldn't be a bad one. We want to execute as few tasks as possible for any given build. So just the story so far, we click run in our app, Android Studio executes a specific Gradle task. That task comes from the android-gradle plugin. That task will run via Gradle's infrastructure. Gradle is designed to avoid doing unnecessary work whenever possible. So our goal then is to configure our builds to do as little work as possible. That sounds good. Developers love doing as little work as possible. So then to understand how to do as little work as possible and where we're doing more work than we need to, we want to be able to profile our builds. You know, what gets measured gets improved. I'm sure most of us have heard this, but this is really relevant for builds. To optimize your build, you need to first understand its behavior. And to do that, we have 4 sort of main monitoring tools. There's probably more, but these are the 4 that I kind of think about most of the time. We have just the raw Gradle build output. We have Android Studio's build analyzer. We have Gradle Buildscans, and then Gradle Enterprise. So we're going to talk about the differences and how these fit together. So Gradle build output is really just kind of what we see here in this terminal. We see build successful in 695 milliseconds, 1 actionable task, 1 executed task. This isn't particularly interesting because there wasn't a lot there, but this is the type of output that we get. It lets us know the build time, the number of tasks executed, the number of tasks from cache or up to date, the status. So that's a very sort of low fidelity way of learning more about how much in our build is running. We want to, at this point, we want to see more things sort of up to date or from cache. If everything is always being run, it means we probably have some work to do. Android Studio's build analyzer then is a new feature that was added in Android Studio 4.0, and it attempts to sort of give us some of this information without having to know so much about Gradle. So it tries to basically make it so you don't have to pay attention to anything that I've been talking about here, and it'll just try to like point you in the right direction. It looks something like this. So if we kick off a build and you look at your build output in the build window, it normally defaults to this build output view here, where you see the Gradle output on the right side of the screen in the console. If you select the build analyzer tab, then you're typically defaulted to this overview. The overview will tell you sort of how long the build took to finish. It'll sort of call out what part of that was from configuration, what part of that was from execution. It'll sort of give you some hints as to like memory utilization optimizations you could make. If you go to the tasks view, it can then show you which tasks were slow. It'll show you which tasks are coming from like Android, Java, Kotlin plugins versus other plugins versus project custom plugins. You can actually group by plugin to see where your tasks are coming from. So in this case, we see most of these tasks are coming from the Android plugin, whereas just the compile debug Kotlin is coming from the Kotlin Android plugin. So this is, again, it's a helpful tool. It's not super high fidelity. It doesn't give us as much detail as some of the others, but it's, again, not a bad place to just try and start figuring out like, what is the state of my current build? So those 2 that we just saw, the command line output, the Android Studio build analyzer, they're helpful for our own builds, like on our machine, but they're not really helpful for profiling across machines. It doesn't help with CI builds. It doesn't help understand what's going on your teammates' build in Africa when you're here in Seattle with me. So we need other tools to be able to do that kind of stuff. And that's where Gradle Buildscans come into play. Basically, Gradle Buildscans, they're a detailed report of a specific build, and they're easily shareable between team members across machines. They tell us a number of things. They give us execution time, configuration time. You can query them. We get outputs, project structure, environment details, cache hit miss reports, test outputs. We get a lot of things here. And if we just quickly want to take a look, this is what a build scan looks like. So this is a build that I generated from Android Studio. And if I do things in here, like go to my timeline view, I can start seeing all the tasks that run. I can order these by which task was the longest. So it looks like this merge xdex debug task took the longest to run. I can filter these tasks. So I could look for any task that was successfully run, but is also cacheable. If I had tasks here, this would signify that there are some tasks that while they are cacheable, they're not being cached properly. And that would be a good place for me to start looking to ways to optimize my build. I can come down to sort of the infrastructure tab and look at the details about my machine, see how many CPUs I'm working with, how much memory was allocated to this. So this is really the place to get really, really fine-grained details on a build, and not just your builds, but builds coming from CI, builds coming from your teammates, builds coming from different projects. It's a really, really helpful tool. So to generate a build scan, then there's a couple ways to do it. The first step, or the first basic way to just try it out, is that you can add --scan to the end of any Gradle wrapper invocation. Then you'll have to sort of accept a terms of service. It'll generate a link for you. You have to enter an email address. You click the link in the email, you get a build scan. So it's a lot of work the first time. The second time you do it, or subsequent times, you won't have to do the email step. So it'll just give you a URL in the build output in the terminal. You click on it, you get your build scan. However, that's still a lot of work. It's still not ideal. It sends it off to some external server. So for like enterprise scenarios, this might not be acceptable. So there's other things we might have to do. We can use build scans to look at diagnosing build failures on CI or local machines, looking for cache misses. Really, really helpful in helping us analyze trends. Now, to analyze trends across a team and across time, historically, we need one more thing here. And that's where Gradle Enterprise has come into play for our team. Gradle Enterprise is really all about sort of helping facilitate developer productivity engineering, like we talked about at the beginning. This is a tool that it's a paid tool from Gradle, but basically it lets you do things like store your build scans on a remote server that you can control for historical access. You can automatically store build scans in a single location. You can set up a remote build cache to help make your builds even faster across machines and across branches and such. And then it also has a lot of useful tooling for analyzing trends in configuration time, build time. You can filter statistically significant events, a lot of information available to us in here. So just sort of anecdotally, we've been using Gradle Enterprise. We've identified build cache issues across local builds and CI builds that we wouldn't have found otherwise. We've been able to identify regionally specific build cache issues where our build caches were working poorly for developers in certain regions. We've identified significant build regressions due to AGP and its handling of NDK versions that we wouldn't have been able to find otherwise. And it also helps us quickly diagnose build failures for our distributed team. So, and I'll just call out here, like I said, it is a paid product, but for our team, it's been incredibly valuable. So if you're in an organization that is looking to speed up your build, this could be something for you to look into and investing in better builds. Okay, so we're running very short on time. So I'm gonna go very quickly through a couple of the optimization highlights, and then we'll kind of wrap things up. So first on, again, you could share this with your managers if you want. Give your devs faster machines. Invest in faster CI machines. Basically, slow build times the cost per dev equals the money for faster hardware. If you have a tool like Gradle Enterprise, it's actually very easy to use that to make a business case of why investing in faster machines is worth it. But it's right there. If you can make a good argument for why faster laptops would help you do your work, I think it's very easy to justify and it will pay off. Next one. This is one, again, if you take away anything, this could be a good takeaway. Enable your local build cache. You can do so by simply adding org.gradle.caching equals true to your gradle.properties file. And this will start caching things in between builds so that if you do, let's say, run a clean build, it's not going to rebuild everything the next time. It's just going to pull it from the cache. So this is super powerful. Similarly, remote build cache, which is the same thing, but it'll let you work like across machines. So if a developer in sort of Berlin builds something and pushes artifacts to the remote cache, you could pull them down in Seattle. Configuration caching, this one is very experimental. Theoretically, it can work, although it's pretty, it's limited for Android builds right now. Basically, you have to have plugins that kind of opt into it and support it. So maybe not quite ready for all of our Android projects today, but it is coming and will speed up that configuration phase. Parallel execution. This is another one, very simple to turn on. And if you have multiple modules in your project, you can start building them at the same time. And if you have a well sort of separated build with lots of modules that aren't highly coupled, this can be really, really powerful in speeding up your build. And again, most of these are just things you need to add to Gradle.properties. So in this case, you could add org.gradle.parallel equals true to your Gradle.properties file. File system watching, this is on by default if you're using Gradle 7 or above. If you're not on Gradle 7 or above, you can add it by adding this org.gradle.vfs.watch equals true. Basically, this just like pays attention to the files that are being worked with as part of like the IO operations of your build. And it kind of keeps an in-memory cache, and it can use that to speed up operations in the future. Allocate more memory to your builds. Gradle can be memory intensive. So if you have a big beefy machine with 32 gigs of RAM, if you can afford to give 4 gigs of memory to your build, or maybe 8 gigs of memory, you can play with those numbers to see if you can speed up your build and basically spend less time in garbage collection. Similarly, you can give more memory to the Kotlin compiler. And very similarly, you'll have to play with this and see how much memory you can give, but it could speed up the build. When configuring memory settings, it's very important, though, to remember that you are running on environments with limited resources. So you need to be aware of the total memory footprint being sort of the Gradle daemon memory plus the Kotlin compiler memory times like the number of separate build processes you have going. So you want to be aware of that. You don't request too much memory. Also be aware that like your machine might be different than your teammate's machine might be different than your CI machine, and you might have to change the memory settings accordingly. Another really big one here. If you do builds from Android Studio and the command line and you're jumping back and forth between them, you need to make sure that you're using the same JDK for both sets of builds. You do this by setting Java home, pointing it at the JDK that you want to use, and then in Android Studio, configuring it to use the Java home JDK rather than the embedded JDK. If you don't do this, then each one will use a separate Gradle daemon, and you'll basically run into that scenario where you're duplicating all of that allocated memory, and you're also not taking advantage of the same cache and everything. So your builds between Terminal and Android Studio will actually be totally separate and be a lot slower than you would expect. Modularize your project. This is super helpful. Most of us are probably familiar with this. I'm not going to spend too much time on this one. Reduce the use of kapt. Kapt is really slow for Kotlin builds. Avoid annotation processors if possible. Limit them to specific modules when you can't avoid them. Consider using Kotlin symbol processing when it's available. Keep your libraries up to date. This is just helpful because you pick up bug fix improvements, performance improvements, etc. And build only what's needed here. You know, don't minify your build on CI if you don't need it to be. Don't build multiple variants if you don't need them. Just be mindful of what you're building. And now this is another one that's really worth taking a look at. The android-gradle-cache-fix plugin. This can help you sort of fix known build cache issues in AGP. It's basically like a stopgap until AGP can fix them and release a build. This sort of lets you fix them temporarily. Basically add this plugin to your project and hopefully start seeing more cache hits and faster builds. All right. So to maintain our builds then, once we've done all of this work to optimize them, we want to make sure they stay fast. So we want to monitor and analyze builds. Like I said, we can do this with Gradle Enterprise. We can also use a plugin called Gradle Doctor. This is another one where you just add this to your project and it'll start doing things for you like diagnosing common issues. It gives you configurable warnings for things like build speed issues, annotation processing times, mismatched GADKs, building all variants. Basically, it helps call out a lot of the things we just talked about. So again, look at the Gradle Doctor plugin, add it to your project, and just see what kinds of things it warns you about. Benchmark your builds. We can use the Gradle Profiler, which is a kind of a command line tool that basically will let you run multiple builds, maybe 5 builds, 10 builds, 20 builds, and aggregate all the results to you and give you statistically significant information about whether a change impacted your build. So maybe you enable the cache, you could profile and see what the performance was before and after the cache, and it'll let you know, yes, this increased build times by 30% or decreased build times by 40%. Really helpful. You can run it manually or you can automate it. And again, keep your projects up to date. The key thing here is also making your builds easier to work with. The more people are comfortable building or working with your build, the more likely they are to keep it up to date and keep things fast. All right. So to just wrap things up here, to kind of bring it full circle, Android relies on the Android Gradle plugin and Gradle to build our projects. Gradle provides the infrastructure and the plugins provide the functionality. There's very little magic behind the scenes. Tasks and plugins, they're really just sort of classes and functions that we can go in, we can find the source code for, we can write our own, and we can start to learn what's going on underneath the hood. To speed up our builds, we can use faster hardware, do less intensive work, or just do less work. Tools such as Buildscans and Gradle Enterprise can help us diagnose build issues. And we can then optimize our builds through things like caching, modularization, and other build acceleration strategies. By monitoring and profiling performance, we can maintain that efficiency over time. And then lastly, we really want to develop a culture of continued investment into developer productivity for happier, more productive teams. And that's it. I apologize for running over, tried to fit way too much time or way too much into this time slot, but I appreciate you sticking with me. I've got a couple minutes here. I'm happy to answer questions, and then I'll also hang out in the Slack channel and answer some more questions. Let's see here. So just looking back through the chat here. So one of the questions I see is, what's the difference between Gradle and the Gradle wrapper? Basically, the Gradle wrapper sort of just makes executing Gradle easier. It makes it more portable. It basically provides sort of a script around sort of installing and being able to execute the Gradle tool. So you can install Gradle and set it up separately and add it to your path and execute it the way I did when I was doing Gradle init. But the Gradle wrapper basically makes it so that any Gradle project with the Gradle wrapper in it can just immediately be executed without having to do that step first. There's another question. How do you accept the terms of service / like confirmation email thing on CI for Gradle Buildscans? And that's a good question. I don't like, you'd have to get really clever on how to automate the email part of it. You could probably script out the terms of service confirmation part of it for CI. I think though, I think if you were wanted to do this on CI, you would really want to have something like Gradle Enterprise in place to do that, because you would want to have the historical record of all the CI builds. And if you are using Buildscans with Gradle Enterprise, then they have a Gradle Enterprise plugin that actually makes this really easy and basically lets you just write that out once in a build script, and they'll just automatically accept it and do all of that for you. So using Buildscans with Gradle Enterprise actually has kind of a streamlined workflow to solve that. What's an example spec for a decent dev machine that you'd recommend based on your experience? RAM, SSD, CPU, et cetera. And what are thoughts on M1 laptops? So in terms of machine recommendations, having multiple CPUs I think is really helpful if you start doing things in parallel, but then also having significant memory. So like a quad core with 16 gigs of memory would be doing really well. 32 gigs of memory and you know, like a hexacore or octa-core or something really good. I mean, kind of a cheeky answer is like just the most powerful machine you can get to some extent. You know, you might eventually hit diminishing returns because of thermal throttling or something. But definitely making sure you have RAM. That's a big one. You want at least 8 gigs of RAM. Really, you want probably at least 16 gigs of RAM or more. In terms of Apple's M1 laptops, I'm super excited about them from like the CPU performance standpoint. Not all of the tooling is totally ready to support the M1 architecture yet. So I think it's a little early to start doing all of the dev work on an M1, but I'm really excited about that. And I don't think we're that far off. I think we just need to make sure that like Gradle, AGP, some of the other common plugins and everything are ready. How do we get a deeper knowledge of how Gradle works? The docs are a mess to me, and I don't have this problem with other technology I've worked with. Yes, it's definitely hard to understand. For me, I've learned a lot by looking at plugins and sample projects from people that I know know Gradle better than I do. So a few people that come to mind, Zach Swears has a project called Ketchup that has some cool Gradle configuration in it. Tony Rubalik, Nelson Osaki, they have some really helpful plugins. Some of those plugins we looked at, like the Gradle cache-fix plugin, Gradle Doctor, those kinds of things are really helpful. So kind of just like reading stuff. There are some, Gradle does a lot of really good developer trainings on like deep dives into how Gradle works, how build caches work. Those are really helpful. They're free and they do them all of the time. So I could recommend those. And then starting to just like play around with my own builds a little bit more. Buildscans help a lot as well, like being able to understand what's going on in certain scenarios. Without Buildscans, that would have been so much harder. Is Gradle Enterprise pricing prohibitive? I don't think so. Like we worked with Gradle to optimize our build, and then they helped us set up basically sort of like a business case for like, here's how much we've saved in build times, here's how much it costs per developer. And it was a very clear win. Like the productivity savings we got from using all this stuff and working with them far outweighed the cost per developer for having Gradle Enterprise. So for kind of I don't know, a small to mid-sized startup, it wasn't an issue. So I don't know what it would be for your team, but you can definitely talk to those folks. They're great to work with, and they could answer more of those questions. Okay, I think that's everything from the chat. And thank you to everybody. I see there's still a fair bit of people here and we're way over. So thank you for sticking with it for that long. Feel free, if you have more questions, feel free to like ping me in the Slack channel or find me on social media. More than happy to continue chatting about this stuff. I love chatting about this. Happy to answer questions you might have.